notebook. All right, so this is probably your first introduction to the word limits. Yes? Have you seen limits before? All right. I didn't give it to you in a paper. I posted it in the notebook, or you can just write it on your paper. In calculus, a lot of what you deal with in calculus is talking about the limits. What are the limits of this function? So this is your first experience with it. We're going to use limits to find the end behavior of these polynomials, and then we're going to compare this to what you did on the discovery sheets and the math lab that you turned in to me today. So when dealing with limits, what we do is my pen dead? All right. Apparently, my battery is dead. Okay. I don't know if I can do this without my pen. As what we do is we're going to put infinity in everywhere there's an x, right? So
are we supposed to do that every time, or is it just supposed to be for example?
Okay. Ladies, stop talking. Shh. What I had you do in the math lab was a discovery. Jimmy, where are you?
Right here.
Okay, all right. Was a discovery and a way to memorize limits and end behavior. This is a way that you can always use in any function, in any class, and what you will use in calculus to find the limit, right, of any kind of limit, not just end behavior. The way this works is we have the limit as x approaches positive infinity for f of x. So what we want to do is everywhere there's an x, here, here, and here, everywhere there's an x, we're going to change that x into infinity, into positive infinity. Now, my highlighter's too dense, you can't see through it. Right? So if I have positive infinity and I cube positive infinity, it's just more positive infinity, right?
Yeah.
Right? If I multiply that by a negative 2, now I've reversed it, so it's going towards negative infinity, right? If I put infinity in and I square it, positive infinity, well, that's positive infinity, but infinity squared is less than negative 2 infinity cubed, right?
Yeah.
So we're still negative. Then I have positive infinity times negative 11. Well, that's more negative infinity. So we just went more negative, right?
Yeah.
So the limit as x approaches f of x is negative infinity. Because we can add 2 to it, but, if you're already at infinity, adding 2 doesn't matter.
Can you re-explain that?
Yes. Let me see if I got enough juice on my pen. Yeah. All right. So what we said was, we have negative 2 times infinity, positive infinity cubed, plus 4 times positive infinity squared, minus 11 times positive infinity, plus 2. All right. Positive infinity cubed is really, really big. And then we make it negative by multiplying it by negative 2. Then we're going to add positive infinity squared, but positive infinity squared, wherever that is, it's way less than infinity cubed, right?
Yeah.
So we're not as negative as we were, but we're still negative. Then we take negative 11 times more infinity, so we're negative 11 more infinities, so we're more negative. We add 2 to it, so what? Adding 2 to infinity is negligible. So the limit as x approaches infinity of f of x is negative infinity. It's negative infinity. This function is going to negative infinity on the right. You can memorize the other things that I told you, but if you can understand this and what we're doing, then you're a step ahead for things you're going to have to learn and do in calculus. All right, so now let's look at the second one, still f of x, but now we want x is negative infinity. So now we're going to have negative 2 times negative infinity cubed. All right, a negative number cubed is what? Negative. And then when we multiply that by a negative 2, it's now positive. So we're now at positive 2 times infinity cubed. Right?
That means it's going to be going to infinity.
So then the next part is plus 4 times negative infinity squared. Well, negative squared is positive, but we are, okay, so we're very, very positive, right? Because this is positive right here. Because we multiply the negative times the negative. So this is positive infinity cubed. This is positive infinity squared. I mean, times 4, but that just makes it bigger, right? So we've got infinity cubed, and we got 2 infinity cubed. We've added 4 infinity squareds. And then we have minus 11 times negative infinity. Well, that's more positive. And then we add 2 more to it. So if we put in negative infinity in f of x all the way across, we get positive, 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 positive. It's positive infinity. So the limit to this one is positive infinity.
What is the velocity?
Miss, explain to us like we're 10.
Okay. You want me to start back at the first one? Or start with the second one?
All of them, miss. Do all of them again.
Wait, did you give us a paper? No.
I put this in OneNote for you, and you can write it on your paper or you can write it in your notebook. All right. Those are already written. Let me start with G. So we're going to start with number 3. I'll put it down here. We want to know the limit as x approaches positive infinity of g of x.
Yeah.
All right. So g of x is negative 4. And then we're going to, instead of x, we're going to put positive infinity to the 4th power. Right? So if we're way out somewhere at positive infinity, some number, wherever that is, at positive infinity, and we raise it to the 4th power, we're now like way, 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 way positive, right?
That's a big number.
That's a really, really, really big number. But then we're going to multiply it by negative 4, so now it's a really, 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 really small number. It's way negative. Right? We took positive infinity, we raised it to the 4th power, and then we multiplied it by negative 4. So now we're at somewhere very far negative. Then we have negative 3 infinity squared. Positive infinity squared is positive, but we multiply it by negative 3. So now we're subtracting more negative infinity. Now we're more negative infinity. No, it sounded like I was. Let me erase that. So the negative 3 times that is even way more negative infinity. Then we're going to add positive infinity, but adding 1 positive infinity when we've got negative infinity to the 4th and squared and multiplied and everything else, this is negligible. Oh, I didn't mean to erase it. This part right here is negligible. It's like saying I have negative 10 trillion, and I'm going to add 1,000,000 to it. Are you listening? Because it doesn't do me any good to explain it if you're not paying attention. Ladies, stop. Shh. Shh, 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 shh. If I've got negative 10 trillion,
Yeah.
even if I add 1,000,000 to it, I am still very, very negative, right? Okay, so that's what happens when we add this positive infinity right here. And then finally, we subtract 12. Well, that's like having negative 10 trillion and subtracting 100. Negligible. So this function, g, as x is approaching positive infinity, this function is getting more and more and more negative.
So right now the h of x and the p of x are not.
We haven't done h of x and p of x yet, but we've done, this one is g of x to positive infinity. So the limit of g of x as x approaches positive infinity is negative infinity. Questions? This is conceptual thinking. Ladies up front, please stop talking because you're going to have this, you're going to be tested on this. So you need to try to understand it. Okay. So if we look at number 4, now we're talking about g of x as x approaches negative infinity. Right? So let me change colors.
Miss, can you erase what you've done already?
Yes.
All these numbers are confusing.
All right. So then I don't change. I want to change colors. Well, I would have had to undo a lot. It was easier to erase it. So now we want the limit as x approaches negative infinity of g of x. So we have negative 4 times negative infinity to the 4th power. All right, a negative number raised to the 4th power is what? Positive or negative?
Negative.
To the 4th power?
Positive. Negative. It's negative.
Negative times a negative times a negative times a negative
Positive.
is positive.
Zero. Let's go.
But then we multiply it by a negative 4, so this is very, very negative. Right? Infinity to the 4th power and then multiplied by a negative number, it's like a gazillion, whatever, to the left. So then we want negative 3 times negative infinity squared. All right, a negative number squared becomes positive or negative?
Positive.
Positive. And then we multiply by negative 3. So now we're going more negative. And then we have plus x, which is negative infinity. So it's more negative. And then we're going to subtract 12, so we're going to go a tiny little bit more negative.
So x approaches negative infinity, going negative.
G of x is approaching negative infinity.
Stop flirting with the teacher.
Yes. So the answer to this one is negative infinity. The answer to that one was negative infinity. Okay. You try H, number 5 and 6.
I don't want to. I don't want to.
H only has 3 terms.
You work at Chipotle?
Can I get a discount?
Okay, you're supposed to be doing 5 and 6. Write it on your paper. Do 5 and 6.
Mark, help him, he's stuck.
I'm leaving you to your misery.
Mark, sit down and do this, please. We only have a few minutes left. Mark, go sit down and do this. 5 and 6. Okay, you can't disturb them. They have to be doing this because we go to the assembly in a few minutes. Everybody should be doing 5 and 6. In number 5, plug in positive infinity for the x's in function h. In number 6, plug in negative infinity for the x's in h. Psst. You got to stop disturbing them. They need to do this problem. Have you covered limits yet?
Miss, would 5 go
Have
to
y'all covered
infinity?
limits yet?
Miss, would 5 be positive infinity?
Yes.
Wait, miss, so what's the difference between going, so 5 is, in the little thing it says going to infinity?
Yes.
6 is going to negative infinity.
That's right. You plug in a negative infinity instead of the x for number 6.
You losing is negative infinity and 5 is positive. 6 is negative.
Infinity and 5 is positive infinity. Yes, that's right.
5 is positive infinity and then 6 negative.
So the people who've done it, this is positive infinity, and this is.
Write out how we did it, or like,
If you can do it in your head, I'm fine with that. I want you to understand
it
it.
just like it doesn't have any negative or positive,
Miss,
so you
why?
just plug
I
it in.
wasn't
And
done.
that's
That's what it is. Yeah,
Miss, why would you give me the answer? I'm not done.
because Carla gave us the answer.
I didn't.
Okay, now
No point.
I need 5 more minutes, and then you're going to need to put your stuff away. If I look at h, what is the degree? Now, realizing when it's adding like that, the degree is the highest exponent. So what's the highest exponent in h? 5, which is even or odd? Odd. What is the leading coefficient? Please stop talking and laughing. Ladies. 5 is even or odd? And the leading coefficient for h is what? Positive or negative? Positive. So if on the papers you did today, you discovered that when the degree is odd and the leading coefficient is positive, the function goes up on the right. So, remember this paper? I told you to put it in your notebooks, in your binders, and keep it. When the degree is even, guys, stop. I want you to listen to me when I'm talking. Shh. This paper that I gave you at the beginning of the year, and I told you to keep it in your notebooks or binders, whatever you're keeping your stuff in. Even degree positive coefficient is up on the right. And even, both ends go the same direction, so it's up on the left. So that's an even one. Odd, which is degree 5, positive coefficient is up on the right. See, it's going to positive infinity on the right. But as it goes to negative infinity on the left, the answer to 6 is negative infinity. This chart represents that process. So you can memorize this chart, but eventually, before you get to calculus, you're going to have to understand doing it this way, because you're going to look for limits for other things besides in behavior. What?
Nothing.
Somebody messed it up? Okay? So this is in behavior, but using limits.